Hello and welcome. In this session, we are going to discuss quadratic equations. Introduction. A quadratic equation is a polynomial equation of degree 2. The standard form is written as ax squared plus bx plus c equals 0. In this form, the value of a cannot be 0. A is the coefficient of x squared. B is the coefficient of x. C is the constant term. If equals 0, the equation becomes linear and is no longer quadratic. Examples of quadratic equations. Here are some examples of what these equations look like. Example 1 is x squared plus 5x plus 6 equals 0. Example 2 is 2x squared minus 7x plus 3 equals 0. Example 3 is 4x squared equals 9, which we rewrite as 4x squared minus 9 equals 0. For comparison, these are not quadratic equations. X cubed plus 2x plus 1 equals 0 is not quadratic because it is degree 3. 5x minus 2 equals 0 is not quadratic because it is degree 1. Graph of a quadratic equation forms a specific curve called a parabola. If the value of a is greater than 0, the parabola opens upward. If the value of a is less than 0, the parabola opens downward. What are roots of a quadratic equation? Roots are the values of x that satisfy the equation. A quadratic equation can have two real roots, one real root, or no real roots. The maximum number of roots an equation can have is 2. Method 1 Factorization method. There are a few major techniques used for algebraic factorization. 1 Taking out common factors. 2 Regrouping or splitting terms. 3 Using algebraic identities. 4 Splitting the middle term. Often used for quadratic expressions by splitting the coefficient of x. Factorization example. Let us factorize the expression x squared plus 8x plus 15. First, find two numbers whose sum is 8 and whose product is 15. Those numbers are 3 and 5. Next, rewrite the middle term to get x squared plus 3x plus 5x plus 15. Group and factor the terms to get x times the quantity x plus 3, plus 5 times the quantity x plus 3. The final output is the quantity x plus 3 times the quantity x plus 5. Method 2 The quadratic formula. For the equation ax squared plus bx plus c equals 0, you can always use the quadratic formula, x equals negative b, plus or minus the square root of b squared minus 4ac, all divided by 2a. This method works for all quadratic equations. Discriminant and examples. The discriminant. The term inside the square root of the quadratic formula is called the discriminant. It is represented by the capital letter D. The formula for the discriminant is d equals b squared minus 4a circa. The value of the discriminant tells us the nature of the roots. If d is greater than 0, there are two distinct real roots. If d equals 0, there is one real repeated root. If d is less than 0, there are no real roots. Example using the quadratic formula. Let us solve the equation, 2x squared minus 4x minus 6 equals 0. In this equation, a equals 2, b equals negative 4, c equals negative 6. First, we calculate the discriminant, d equals negative 4 squared, minus 4 times 2 times negative 6. This simplifies to 16 plus 48. So, d equals 64. Now we plug this into the quadratic formula. X equals 4 plus or minus the square root of 64, all divided by 4. This gives us x equals 4 plus or minus 8, divided by 4. Our two solutions are x equals 3, x equals negative 1. Important points to remember. The standard form is ax squared plus bx plus c equals 0. The coefficient a cannot be 0. There is a maximum of 2 roots for any quadratic equation. The discriminant determines the nature of those roots. The quadratic formula works for all cases. Conclusion. Quadratic equations are fundamental in mathematics. 2 methods to solve. Factorization. Quadratic formula. Practice regularly to master the concept. Thank you for watching. Please subscribe and like the video, and click the bell icon for more updates.